Hello guys, I'm Sandip, physics faculty in IIT-JEE, and if you do remember in the previous session, we have started the brand new chapter that is motion and time, right? Okay, so what we have studied in that? Anybody remember what we have studied? So we have seen some basic terms about the motion, right? So in motion, we already know what is the distance and displacement. Distance is a scalar quantity. Displacement is a vector quantity. We need the direction also. Direction is also important. From home to school, school to back to home, right? We know that displacement distances are different for these two cases, right? It's all that. Okay, so and then we also seen some velocities and instantaneous velocities, average velocities, then average speed, right? Again, speed is a scalar quantity. Velocity is a vector quantity. And also acceleration, we talked about that. Bike has some acceleration, right? That thing. Okay. So now, today, let me ask you one question. Suppose you went on the terrace of a high building. Let's take your building, right? Where you are living right now, there are maybe many flats are there, or if you have some bungalow type, right? We will go to the terrace. You will go to the terrace, and now consider you want to measure the height of that building, right? You are I want the height of that building. You don't have any tape or scale or anything, right? So how you can measure that? Very simple thing, right? Not a very simple thing, but if you do know the physics, you can. Right? Okay, let me give you a watch. Watch means what? Watch can measure time. We know that part, right? So take a watch with you, and I will tell you measure the height. How you can measure, right? Okay, so today we are going to see that. Okay, so if you know this motion concepts very clearly, and today's topic, that is kinematic equations, if you know these things very clear, then yes, you can try to do that too as activity, that you can measure the height of your own building, right? You just have to use your stopwatch or watch, you can say, and you'll need one stone, right? That's it. Okay, so let's see. So we are going to cover the equations of motion. Those are also called as kinematic equations of the motion. Kinematic equations of the motion are useful for finding the speed or accelerations or distances, or as I said, height. You can also measure the height of the building, right? How? We are going to see that. That's not a big deal. Okay. So now consider, before moving to the equation of motion, we are going to require some very basic knowledge of some curves, right? So consider if I plot the graph versus, let's say, time versus velocity, right? What I'm doing, I'm plotting the graph of time versus velocity. Means what? Consider if you start the bike, let's say at t is equal to 0. If let's say you have some initial velocity, say 10 kilometer per hour, I will say how you can start the bike at 10 kilometer per hour, right? Very easy, right? Just brake, keep the brake, apply the brake, and just give this some acceleration, right? Your speedometer will show the 10 kilometer per hour. Then leave the brake, then your bike will start moving, right? So I can say that initial velocity is 10 kilometer per hour. Let's say in 1 second, or let's say 2 seconds. In 2 seconds, your speedometer is now showing, let's say, 20 kilometer per hour. So if I plot the graph, don't you think it will look something like this? This is my first point. This is second point, right? We know how to plot the graph. In 4 seconds, let's say it moves to the 30 kilometer. Right? Let's say this is 30. In 6 seconds, it moves to the 50 kilometer or 40 kilometer, like this. So this is called as the velocity time graph. Means we are plotting the velocity. Now, normally what we do, we plot first of all, draw one table, right? For a table, if the first row is for time, second row is, let's say, for velocity. For 1 second, let's say velocity is 10. For second, it's 20. For third, it is 30. We can use these values and plot the graph like this, right? So this is the velocity time graph. Now, there is one concept which is called as slope. right? Slope means what? Consider this is the y-axis and x-axis. Let's say these are the 2 points. Let me call this as a y1, and this is the second point. This is the first point, x1, y1, y2, and let's say this is x2. Okay, I want to calculate the slope. Slope means y2 minus y1 divided by x2 minus x1. I can calculate the slope using this very simple basic formula, right? And one more concept we should remember in this graph is slope of velocity time graph represents acceleration. And we know now how to calculate the slope, right? So once you calculate the slope, that slope is nothing but your acceleration. Very simple. So consider this one. If this is my 30, this is 1 point, this is second point. What I will do, I will just write the coordinates. Coordinates means what? In pair, I can write this as x1, y1, and this as x2, y2, right? Same. So here, let's write the x2 is what? 4 seconds. And the y coordinate is 30. Similarly, here I can write 2 and 20. So how to calculate the slope? Very simple. Slope is equal to what? Y2. Y2 is how much? 30. Minus y1. How much? 20. X2 is 4 minus 2. Let's solve this one. So 30 minus 2 is equal to 5 meter per second square. Why I'm using the unit 5 meter per second square? It is the unit of acceleration. And we know the slope is representing the acceleration in this case. Okay. So important thing to notice how to find out the slope, and slope of this represent acceleration. There is one more thing. Area under the curve, area under BT curve represents displacement. So what is the meaning of this? Now consider you started from here. So how much distance you actually went, right? When you are starting the bike, obviously you are moving some distance, right? So how much distance you covered, we can calculate using this formula. How? The area means what? Area under the curve means what? So this is the, consider we want to find in how much distance the bike covered in 2 seconds. I will just draw one graph like this. So this is my curve, and let's find out this area, right? So this is how we can calculate the area under the curve, right? Also, we need one more formula here. This is trapezium, right? So let's say this is OABC. This is called as trapezium, right? So we need the area of trapezium's formula. Let me write it here. So area, yes, if anybody remember, area of trapezium is equal to 1/2 into sum of parallel sides into height. So this is the another formula we are required here, right? So if you use this formula, you will get something like this: 1/2 into sum of parallel side means what? For OABC is our trapezium. Trapeziums, you know, right? This is the trapezium. Let me draw the trapezium somewhere. So consider this is the trapezium which have the 2 parallel sides. So these 2 sides are parallel, right? Not equal. These 2 sides are parallel, and there will be one height like this. Okay. So for this OABC, I can say this is my height, right? So you can see, yeah. This OC represents the height, and this OA and BC are the parallel sides. So what here I can write one thing here, that sum of parallel side means what? OA plus BC into height is what? OC. Let's substitute the value. 1/2 into OA is how much? 10, right? BC is how much? BC is 20 into OC means 2 seconds, right? So let's substitute the values. I will get this as 1/2. I think 2 will get cancelled. So remaining will be only 30 meter. So what I can say, distance covered in this case is how much? 30 meter. So these are some basic concepts we are going to require to this find out these equations of motions. Okay. So So there are three different types of equation of motion. So let's, using this graphical method, let's try to find out those equations. Okay. So here again, I can see one VT graph, velocity versus time graph. You can observe here, when t is equal to 0, the bike had some velocity. Let's call this as initial velocity. So terms are important. So remember, this is initial velocity is represented by u, final velocity is represented by v, acceleration is represented by a, displacement is represented by s, and time is represented by t. So these are the some terms we are going to require for this kinematic equation. How many kinematic equations are there? 3 kinematic equations, right? Okay. So we are going to solve these things. So I can see the graph. I know the two concepts, that the slope represents the acceleration and area represents what? Displacement. Using this, we are going to find 3 kinematic equations. So first kinematic equations look like this. V is equal to u plus at. V means what? Final velocity. U means initial. A is acceleration, t is time. So consider if the initial velocity of bike is 10 km per hour. If the acceleration, consider it's let's say 2 meter per second square, and for 5 seconds we are giving some acceleration there, right? Then we want to find the velocity. How to do that? We can use this formula. So how to derive this formula? First we are going to derive this formula, then we will also solve some questions on this. Okay. So simple. Now just focus on line AB. Focus on line AB on the graph. Right? What I'm going to do, I will write the coordinates of this one. Right? If you do remember, I want to calculate the slope first. What is the formula for slope? y2 minus y1, x2 minus x1. So these are the coordinates. Let's write the coordinates of this A point. What is this x coordinate? Obviously it is 0. Y coordinate is u. Here for B point, x coordinate, sorry, x coordinate we can talk about first. X coordinate is t, right? And y coordinate is what? You can see it is v. Let's use it here. And slope represents what? Acceleration. We know that, right? So acceleration a, y2 is how much? V. y1 is how much? Here you can see u is what? Initial velocity. x2 is t. x1 is how much? Here 0. So what I can say, this becomes v minus u upon t, right? Simple. So let's take this t onto the other side. So I can say at becomes v by v minus u, or I can also write v minus u is equal to at, right? Okay. So can I say v is equal to u plus at? That is our first kinematic equation. Right? We solve this using the slope of the curve. Very easy, very small derivation we can say. Okay, so v becomes u, v is equal to u plus at. Good. Sure. So now let's solve one very small example on that. Consider building, right? We talked about the building. Actually, we want to measure the distance, but our first kinematic equation says what? V is equal to at, right? So this is our v is equal to at. So instead of, we'll measure the distance later. What do you have? You have the stone as well as stopwatch, right? So consider if you throw this stone, right? Or we can say just release the stone. Release means just release any object like this, right? So what is the initial velocity will be here? 0. Now about the acceleration, remember this thing, right? This thing is, we are going to always use this acceleration. Acceleration means what? Acceleration means what? If you release that stone from the terrace towards the ground means the earth, I can say, the earth is going to attract that stone, right? With some acceleration. That some acceleration is called as acceleration due to gravity, g. We know the value of this one, right? That is 9.8. Right? Now, I want to know that at this end point, how much will be the velocity of that stone? right? When it reaches the ground, let's say it started with 0. Acceleration is how much? 19.8 meter per second square. Let's use that. Now consider using the stopwatch. You saw that time required for the stone to reach the ground. It's, let's say, it take 10 seconds. 10 will be 98 meter, right? 19 meter will be very long. 19, yeah. You can say, let's say 2 seconds. It takes 2 seconds. Okay. And what will be the velocity? Simple. Use this normal basic formula. So V is equal to U plus AT, I know. U is how much? 0. Because when you release the stone, it does not have any velocity. What is the value of A? 9.8 into T. We measured using the stopwatch. So your value become 9.8 into 2, that is 19.6 meter per second. So with this speed, it is going to reach the ground or hit the ground, we can say. Okay. So we know how much the velocity, but our question still remains. What I asked you, find out the distance or height, we can say, right? Height of that building. How to do that? So this is our first kinematic equation. Now we are going to move towards our second kinematic equation. Okay. So let's see. So you can see second kinematic equation consists of a displacement, right? Yes is there. And at the start also, I told you one very important thing, that what? That graph, or we can say area. Area under the curve represents what? Area under the curve represents the displacement. That is what we want to derive here. Okay. So let's start. So you want to find out the displacement. So t is equal to 0. This point represents t is equal to 0. Up to this point, that is t point, we want to calculate the displacement. Displacement is what? Area. Area of what? From 0 to t. What is the curve? PQ is the curve, right? PQ is our graph, we can say. So under that graph, whatever is the area, we want to calculate that. Right? This area. Now, what we can do here? Simple. Instead of finding the trapezium, what we will do, just use this triangle is there and rectangle is there. Two things are there. So what I can say, area is equal to area of rectangle. Which rectangle? I also have name. Let's give some name there. This is P, Q, R. Yes, O is also there, right? So O, P, R, yes, is the rectangle. Plus area of triangle. Triangle, which triangle? P, Q, and R. Triangle PQR. Right? Okay. So this area will give me what? Displacement. We already have said that, and at the start, right? Area of the BT curve is going to give me what? Displacement. So area is displacement. Let's find out the area. Now OPRS is rectangle. What is the area of the rectangle? I know the area, right? Length into breadth. Very simple. What about the triangle? Formula: length into or base into height, we can say, right? For triangle, we have base into height. So you can see, as I also said in the previous session, maths is very important for physics, right? So you should have the strong maths calculations. You should be able to do the calculations very fast to solve this type of questions. Okay. Then now consider, let's find out. L means what? Can I say OS? OS is length into breadth is or breadth or height, we can say it is RS plus 1/2. What about the base of triangle? Base of triangle is let's say PR, and height of triangle is how much? QR. Okay, chalo. So use these equations. Let's find out some area. Okay. Now let's talk about O2S. O2S means what? This length. How much is this length? Right? This is nothing but, now consider, let's come back to our this one. Consider, if I ask you from 0 to 4 seconds, how much is the length? Obviously 4, right? Same here you can use. When we are saying 0 to t, length will be how much? T. Let's talk about R2S. R2S means this one. Or I can say on P2 also, right? Let's let's say this is O2P. OP. And OP is what? U, right? Simple. So u. So you can see one term we are getting as u into t, that is ut, plus let's say 1/2 pr. Pr means again this distance. Is it similar to t? Right, that is similar to t. Let's say this is t. Then qr. Qr means what now? What is qr? Qr means this much of distance, right? Let's come back to our original. Consider here, if I ask you what is the this much of distance, what you will say? Subtract 10 from 30. Very simple. That will be 20. So 30 minus 10. Similar. Here what I can say? This is the distance v and this is the distance u. So what is the, let's name this qr. Qr is also similar to, instead of qr, let's say this is p, no? Let's call this as yes point. No, we already have yes, no? P, Q, R, S, T, U, V, W. Let's say W. This is W. And instead of QR, I will write the, or we can say QR is nothing but QR is equal to PW. No? Let me write it here. QR is equal to PW. So PW is y, what? V minus E, V minus U. Let's write here. And PW is nothing but QR, right? So I can write the V minus U instead of QR. Okay. So now, you can check the what we have to prove. We have to prove this part. No? Ut is there. Yes, u into t. I can write this as ut. That's good. 1/2 is also there, but a is not there. Where we can bring the a? For that, we need to take the help of the first equation. We have derived the first equation. V is equal to what? U plus at. This is our first equation, right? I have one term as v minus u. Let's see how we can use this one. So what I can do, it's v. Let's take u here. Then is equal to 80. So I got the v minus u. Can you see these two brackets are same? So using this first equation, what I can write, t into, instead of v minus u, I can write 80. What I can say, using the first equation, simple. Now a, we have 1/2 t into a into t, t is double. So can I say this is ut plus 1/2 80 square. That is what we wanted to prove. Simple. So this is how we can prove s is equal to ut plus half 80 square. Okay. Good. So what we did, just find out the area of the shape, whatever shape is there, then you can easily find out the s is equal to ut plus half 80 square. Right. Now let's come back to our problem. What we wanted to do, we want to find the distance, right? What is the height of that building, right? Okay, chalo. So this is building. You are standing on the top and you now release the stone, which has initial velocity how much? 0. You measured, time is equal to what? 2 seconds, and you want to calculate this height. Now height means what? Stone is going downward. If the stone is going downward, so obviously how much distance it is covering? H distance. In how much time? 2 seconds. How you find out the 2 seconds? You drop the stone. Right? Once you drop the stone, you look at it. When it reaches the ground, you click the stopwatch and you observe that t is equal to 2 seconds. It reaches there in 2 seconds only. Okay. So we also know the acceleration. I told the acceleration is a very important thing. That is how much? 9.8 meter per second square. What we want to calculate? H. H means what? Anyway, H is nothing but displacement. So we already know the formula. S is equal to ut plus half at square. Let's try to use this formula. So yeah, this is our formula. Let's see what values we have. We have u is equal to 0. We have acceleration is equal to 9.8 meter per second square. We also have time. Time is equal to 2 seconds. Okay, so it will be very small building, I guess. So let's say use these values into our formula. So u will be how much? U is 0. So can I say this whole 0 into time is 2 plus 1/2 into a is how much? Acceleration is 9.8 into t square means 2 square. So how much this becomes? 0 plus 1/2 into 9.8 into 4. This 2 will go here, then this become 19.6 meter. Okay, yes means distance or displacement. We can say in this case, obviously it is in the straight line, it is not changing direction. So we discussed this also, right, in the previous session, that if doesn't change the direction, then we know that we already know that displacement and distance are same things, right? So we can say distance or displacement or height in this case. Why? Because it is moving vertical. So it is moving vertical, so it is covering the height, we can say. So height of the tower is how much? 19.6. Right. So this is how you can measure the height of any building. We can say, what do you need? You need just one stopwatch, or even normal watch will also work, right? That's not a big deal. And you need the stone. Stone is, you can get the stone anywhere. So you can easily calculate the height of the tower. Okay. Now let's take one more example of the, let's say, this car. Now consider car has some initial velocity, let's say u is equal to 20 kilometer per hour. Then initially it was going with the uniform velocity of 20 kilometer per hour. Then the driver applies the brake, not brake, accelerator, right? And the acceleration, let's say it is given by, let's say 0. Simple, let's take 1 kilometer per hour, right? It will be easier. So what is the distance covered, right? Question is, what is the distance covered in 5 seconds? Okay. Sure. So let's use the same formula again. Formula is S is equal to what? Ut plus half at square. U is how much? 20 into 5 plus 1 half into 1 into 5 square is 25. Okay. So now it is become very simple. 20 into 5 is 100 plus 25 upon 2 becomes 12.5 or 112.5 meter. Simple. So distance covered will be 112.5 meter, right, in 2 seconds by the car. So this is how we can calculate the distances, whether it could be vertical or horizontal. Vertical means stone we release from the top, and horizontal means car moving or bike moving. They could say anything, right? So once we know the formulas, we can easily find out the distance or displacement. Okay. Now, so we have seen the two equations. First one is V is equal to U plus AT, right? And second is S is equal to UT plus half AT square. So we have seen these two equations, which first gave me the velocity. What will be the velocity after some time? And second give me what? Second give me the distance, how much distance car traveled, or how much is the height of the building. You can easily calculate that now. Okay? Now let's talk about the third equation. So third equation is V square is equal to U square plus 2AS. Okay. So you can say the acceleration is the one thing which is common in every equation, right? Acceleration is common in every equation, and that acceleration is a very important thing. And for this kinematic equations to work, acceleration should be constant, right? So remember, very important thing, that acceleration must be constant. Then only we can apply all these equations. Okay, good. So now this is the third equation, V square is equal to U square plus 2AS. And now what we have to do, we want to derive this equation using the graphical method again. Okay, sure. So yes, how we can derive this one? Okay, so what we can do to derive this equation, right? So we already know the formula for yes, right? So what is the formula for yes? Yes is equal to what? Can I say UT plus half AT square? We use that equation. Let me see, just a minute. Right, so let's try this one. This becomes E minus U, B plus U is equal to 2AS. So yes is equal to 2A. Yes. Okay, so we can use the trapezium's equation. So again, we will start with the displacement. So we already know area. Now, in the previous case, what we did, we actually find out the area of the same shape, same AB curve. You can see the graph is the same, but we have segregated that in two parts: rectangles area and triangles area. Right? We have written area of rectangle and area of triangle. Now, what we are going to do, we are going to directly say area of trapezium. And at the start, we founded the area of the trapezium also. Trapezium what? Which trapezium? That will be A, B, C, O. We want the area of this one. And we know the formula. What is the formula? 1/2 into sum of parallel sides into height. So let's see what is the sum of parallel sides. These two are parallel sides, right? Good. So what I can say, sum will be OA plus BC, right? What about height? If these two are the parallel sides, perpendicular distance between these two sides will be OC. Okay. So we can say this is the area of the trapezium. Let's put the value. So this becomes 1/2 OA. OA means, can I say it is U? Now we know how to find out the distances. What about BC? BC, you can say this is V. So U plus V into OC is how much? OC is time. Okay, so we have written this. And what is our destination? Destination is this one. V square is equal to U square plus 2S, right? We have to prove this part. So what to do now? Again, we are going to take the help of the first equation. V is equal to U plus AT. We know that part. Here I can see one t there, one time. And in equation, there is no time, right? So if in equation, in whatever we want to prove, third kinematic equation, there is no time. So let's do one thing. Let's find out the formula for time from this equation and let's replace it. So what I can say from here, V minus U is equal to AT. Or can I say V minus U upon A is equal to time? Very simple. Good. Sure. So let's substitute it here. 1 by V, 1 by 2. Instead of U plus V, I am going to write this as V plus U. Right? It's not different, right? I will tell you why I have written that. So T is V minus U upon A. Simple. And what is the area? Area represents what? I told you at the start. Area represents acceleration, distance. So this is distance, this is distance, this is distance, and this is also distance. Okay. So now let's take this 2 into A to the other side. So I will get 2A as V plus U and V minus U. Now you can see this 2As, we got the 2As. Very simple. Now let's talk about this RHS side. I have one formula here, A plus B and A minus B. Yes, what is the formula? A square minus B square. So can I write V plus U, V minus U is A square minus U square, right? Simple. Now you must have understood why I have changed this U plus V to V plus U, right? Okay. So instead of this, can I write V square plus U square? Let me write it here. So I will get 2As, all right, in the reverse fashion. V square U square becomes 2As, or V square will become U square plus 2As. This is my third kinematic equation, which I can use to solve some of the questions. Okay. Now what we can find from these equations, either we can find the velocity and displacement, etc. Right? Okay. So we already have find out the velocity and displacement of the building. If you do remember, let's try to solve that. Right? We will recheck our answers. If you do remember what we have, you are standing on the terrace and you drop the stone with who has the velocity U is equal to 0. We already know acceleration is equal to how much? 9.8 meter per second. U is 0. Time you calculated using your stopwatch. That was how much? 2 seconds. And if you do remember, we got the velocity as 19.8 meter per second. And you also got the height. How much? 19. It was also same 19.8 meter. So these are the values we got actually. Now, using this third kinematic equation, that is v square is equal to u square plus 2as. Right? Using this third kinematic equation, let's see whether our answers matches or not. Right? So what I'm going to do, I'm going to use this value of h, right, in this equation. H means what? H means anyway yes, right? Yes is h. And let's first put some values, yes, then u, and then a, and we don't need the time anywhere, right? And let's find out whether we are getting the same v. Okay, chalo. So this is our equation, u square, u is 0, so 0 square is 0. So 2 into 9.8 into yes is 19.8. Okay, so this becomes 0 square is 0, 0 plus anything is that, anything we part. So 2 into 19.8 is how much? 19.8 into 19.8. Right. So what I'm getting, v square is equal to 19.8 into 19.8. Should I multiply this? No. Why not? Because consider if v square is equal to, suppose, let's say 16. How I can write this 16 as 4 into 4, right? Or I can simply write v is equal to 4. So if the two numbers are same, don't just multiply them. Let's remove one number and v becomes, or I can say v is equal to root of 19.8 into 19.8. Two numbers are same, so just take one number outside. 19.8 meter per second. You can see, right? Using this formula, we verified that our answer was correct in that case. Okay. So these are the three kinematic equations, very important, right? Remember, right? So memorize these equations, not very hard to memorize, only three equations. And as I said, those are very important to find the distances and etc. So we have used those all equations in our building, right? So you can do that activity. Go on to the terrace, draw small stone, and measure the time it will take to reach, and find out the height. Ask your parents whether the height you have measured is correct or wrong. Right? Okay, good. Chalo. So let's try some questions, numericals on this one using three equation. Let's first write the equation. What are the equations? V is equal to u plus at. S is equal to what? Ut plus half at square. V square is equal to u square plus 2as. Okay. What we are going to do in the numerical, we are going to write the whatever values they have given. So race car accelerates uniformly from 18.5 meter per second. So let me write u. What is u? Whatever is the initial velocity, that is written as u. So this is given part of the numerical, right? So u is given to 46.1. So v is also given 46.1 meter per second. And in time 2.47. So let's write the time. Time is 2.47 seconds. Determine the acceleration of the car and the distance traveled. What they want us to calculate? First, calculate the acceleration and then calculate the displacement. We have the three formulas. Using this, let's see how we can find out. So V, U, and T are given. Which formula we can use to calculate the acceleration? So let's calculate the acceleration first. Right? So can I use this formula? Very simple. Right? Easy to understand. So let's try to use this formula. So V is equal to U plus AT. V is how much? V is 46.1. U is 18.5. A, we don't know the value of A. We want to calculate. T is given as 2.47. Okay. So what I can say, A into 2.47. Let me take this here. And I can say this is 46.1 minus 18.5. Let's calculate this. Right. So you can do the rough calculations or you can directly solve this one like this. This will become 7 and this is almost 27.6. Okay. And I can say acceleration is 27. Let me recheck this. If you remove the 26. Okay. I think this will become, let me check this again. 11 minus 5 is 6. 15 minus 8 is 7. Yes, that was correct. It's 27.6 divided by 47. Okay. So this is our acceleration. Now we just have to do this multiplication and will is indicate the answer here, right? So 76 This is 3. Okay, you can just shift the points. So 0, 0, 0, and 0, and this will become 247. So it will be closer to 1, 1 something, right? So we can solve this equation using the normal division, right? And you can get the answer, right? So this is your homework to solve the acceleration, do this calculation and solve this one, right? So then we also want to find the distance. So now we also got the acceleration, how to find the distance. So let's use the second formula. S is equal to what? Ut plus 1 half at square. U is how much? U we have 18.5. Then time is given as how much? 2.47 plus 1 half into acceleration. This whole value I can write this as 27.6 and 2.47. I think it must be 2.76. That could have been easier. Okay, no problem. Into t square means 2.47 square. Again, this is the calculation you are going to do as homework, right? So using this kinematic equation, you can easily solve this. Okay. Now let's move to the next question. Again, I know the 3 formulas. Let me write the 3 formulas. T is equal to u plus at. S is equal to what? Ut plus half at square. V square is u square plus 2as. Okay. So car starts from rest. So u is equal to how much? 0. And accelerates uniformly over a time of 5.21 second. Time is given 5.21 seconds. For a distance 110 meter. So S is given as 110 meter. And determine the acceleration. Acceleration we want to find out. So we have the S, we have the U, we have the T. Which formula you can use? Can we use the first equation? No, first equation has V. Can we use the second one? Yes, obviously we can use the second one, right? So let's try that one. So S is equal to what? Ut plus half at square. Okay, so S is given as 110. U is given as how much? U is 0, so this whole term will get cancelled. 1 half into acceleration we want to calculate, and time is given as 5.21, and we need the square of that. Okay. Chalo. So for acceleration, let's treat this 2 on the other side. So I can say this becomes 2 into 110 into acceleration into 5.21 into 5.21. Can I take this 5.21 to the other side? Yes. So acceleration will become 2 into 110 into 5.21 into 5.21. Okay. Now we want to solve this question again. So what we have to do, we have to divide this 110. I can say this is nothing but 220. 5.21 into 5.1. So you have to divide this 220 by 2 times. So you can easily get the acceleration there. Okay. So this is how, if you know the kinematic equations, you can solve the numericals. So there are many numericals, so you can try those. So let's try this last numerical today. So rocket powered sleds are used to test human response to acceleration. Okay, so these are the rocket powered sleds. Sleds means some rocket kind of thing we can say, and it is moving with a lot of velocity. To test the human response to acceleration, if the rocket powered sled is accelerated to a speed of 444 in 1.83 seconds. Okay, so what they have given, this initially they haven't mentioned anything, but initially obviously they will be at 0 velocity, right? And they reach at this velocity 444 meter per second in how much time? 1.83 seconds. Okay, then what they are asking in this case, what will be the acceleration, what will be the distance covered? Again, we already know the formulas, right? We know how to solve this one. V is equal to u plus at. S is equal to what? Ut plus half at square. And what is the third one? V square is equal to u square plus 2as. Chalo. So write these equations. What we have V, we have U, and we have T. What we can find first of all? Let's use the first equation. So V is equal to u plus at. So V is how much? 444. U is 0. A we want to calculate. Time is given as 1.83. Right? So acceleration will be how much? Can I say 444 divided by 1.83 meter per second square? So you will do this calculation. Then we want to find yes. Which formula we can use for yes? We can also use the third one or the first one also. Oh, sorry, not first one, second one, right? So this is ut plus 1 half at square. Now u is 0, so again this term is getting cancelled. So 1 half into what? Acceleration, I can substitute acceleration as it is. Into t square means 1.83 into 1.83. Right? So this 1.83 will get cancelled. So 1 half into 444 into 1.83. Now it becomes, it's easier now. You can just divide this 444 by 2. And whatever is there, you can multiply it by 1.83. Right? That's become easy. So again, you have to do this two calculations. You can get the answers for acceleration as well as displacement. Okay. Sure. So there's a whole thing about the kinematic equations, and using these equations, we know we have seen the applications also, right? How to find the height of the building. Right? That is the activity practically you are going to do with the help of your parents, obviously. Don't go alone on the terrace. Right? Then we can also find out the velocities or distances covered by the car, or that last problem with the rocket sledge, right? We can solve those two easily, right? Okay. So in the next session of this chapter, we are going to study about the graphs of the, whether it could be velocity time graph or displacement time graph. We are going to solve those things. Okay. So anyway, if you do have any questions, please put those questions in the forum, and we'll continue this chapter in the next session. Okay, so we'll stop here. Thank you very much. Have a nice day.